Let's be real, we are all creating a tidal wave of data every single second. Videos, backups, log files, it just never stops, and the sheer volume can feel, well, completely overwhelming. But what if there was a really elegant way to not just store it all, but to intelligently manage it? Well, that's where Blob Storage comes in, and trust me, it's a total game changer.
And this question right here, pulled straight from a developer on Reddit, it just perfectly captures the challenge, right? How do you stop data management from becoming a full-time job and a huge expense? You obviously can't keep everything forever, but cleaning it up by hand, at scale, that's a complete nightmare. The solution, it lies in thinking about storage architecture in a totally different way.
So the answer to this whole puzzle begins with a deceptively simple idea, the blob. And please don't let the funny name fool you. It is hands down one of the most powerful and fundamental building blocks of the modern cloud.
Blob actually stands for binary large object, and the key word you really want to focus on is unstructured. What that means is a blob just doesn't care what it's holding. It could be a 4K video, a system log, a massive database backup, your family photos, anything. It's like a universal digital container, which is exactly what makes it so perfect for handling the crazy variety and volume of data we're all creating today.
Okay, this slide right here highlights a really critical difference. You've got your traditional block storage, the kind used in servers, which chops files into these little fixed-sized blocks for super high performance. But object storage, which is what powers blobs, is a whole different beast. It treats each file as a single, self-contained object with its own descriptive data and a unique ID. So instead of a complicated folder structure, everything just lives in one massive flat space. That right there, that is the secret sauce. By getting rid of all the overhead of a traditional file system, it becomes almost infinitely scalable.
So, you're probably thinking, if it's just one giant flat space, how on earth do you organize all that chaos? Well, the system is actually beautifully simple, and it's the key to how this whole thing works so well.
The hierarchy is just elegantly simple. At the very top, you have your storage account. Just think of that as your unique address in the cloud. Inside that, you create containers, which pretty much act like folders to group your related files. And then finally, inside those containers are the blobs themselves, the actual files. This simple three-level structure is so lightweight and efficient, which is exactly why it can manage petabytes of data without even breaking a sweat.
And you see it being used literally everywhere. It's perfect for serving up static things like images for a website, because it's cheap and globally accessible. It's absolutely ideal for streaming video, because you can just pull a massive file as a single object. And its incredible scale makes it the go-to for colossal backups and the huge data sets you need for things like AI and big data. Blob storage really is a foundational pillar of the modern web.
But look, just storing the data is only half the story. The truly intelligent part, the part that saves you a ton of money, is how blob storage manages the data's lifecycle. It understands a simple truth. Not all data is created equal. The value of a file and how often you need to access it changes over time, and your storage costs, they should absolutely reflect that.
This is all done through what are called access tiers. Think of it like this. Hot is for data you need right now, like the images on your homepage. It costs a little more to store, but getting to it is instant and super cheap. Then there's cool, for data you access less often, maybe like monthly reports. Storage is cheaper, but it costs a little more to retrieve. And finally, archive is for the deep freeze, long-term backups you hope you never have to touch. The storage is dirt cheap, but getting it back takes time and costs more. The genius is in automatically matching the right data to the right tier.
Okay, so let's circle all the way back to our developer from Reddit. How do we automatically manage all this data and move it between tiers, or even delete it? Well, this is it. This is the aha moment where the true power of this architecture just shines right through.
The solution is automation, and it's done through simple yet incredibly powerful rules. Don't let the text on screen scare you. It's not complex code. It's just a clear instruction. It's basically saying, if a blob hasn't been touched in 365 days, then delete it. That's it. You define these lifecycle policies, and the system just handles the rest. This is the absolute key to automation at a massive scale.
And as you can see, you can do way more than just delete things. You can set up rules to automatically move data down this virtual conveyor belt, from hot to cool after 30 days, then maybe from cool to archive after 180. You can even filter which specific files the rules apply to. This is the exact solution our developer was looking for. It puts the entire data lifecycle completely on autopilot. So what's the financial impact of all this automation? It's huge.
Research shows that by using these kinds of intelligent lifecycle policies, companies can move a much bigger chunk of their data. We're talking from 25% up to 38% into those super cost-effective cold tiers like Cool and Archive. At enterprise scale, that translates into massive, massive savings.
So the real takeaway here is this. We have to stop thinking of cloud storage as just a passive data dump. It's not a digital closet you just throw things into anymore. It is now an active, intelligent system that works for you, constantly optimizing for cost and compliance, all on its own. It's how you truly tame that data deluge without drowning in complexity.
And that leaves us with a pretty fascinating question to ponder. We've gone from just storing files to being able to fully automate their entire lifecycle, from creation all the way to deletion. As our universe of data just keeps expanding exponentially, what new levels of intelligence are we going to need to build into our storage systems next? Definitely something to think about. Thanks for watching.